Hello everyone, myself Saddam Hussein from CSE department. Now I am going to explain about cryptography and crypto. Okay, this is cryptography and crypto. Okay, basically introduction. Okay, basically what is cryptography? Cryptography is nothing but hidden writing. Hidden writing in the sense the information is protected using the cryptography, and it can ensure confidentiality, integrity and authenticity. Okay, next in cryptography we have certain terms. The terms are plain text, ciphertext, key and crypto system. What is plain text? Plain text is a message in its natural format readable by an attacker. That is, plain text can be readable by the everyone, so that it becomes easier for the attacker to attack the information. Okay, this is a plain text. Next comes ciphertext. What is ciphertext? Ciphertext is message altered to be unreadable by anyone except the internet recipient. In the sense, ciphertext is the message that is readable only by the authorized persons. Then it can't be readable by the any other recipients. Okay, that is ciphertext. Then we have key. What is the key? Key is the sequence that controls the operation and behavior of the cryptographic algorithm. That is, this key is used for the encryption and decryption algorithms. Okay, then you have crypto system. Crypto system is nothing but the combination of algorithm, key management function used to perform the some cryptographic operations. Okay, these are some combining all the algorithm, key and key management to perform some cryptographic operations. That is this. Then we have crypto system services. What is crypto system services? Is nothing but we have data confidentiality, data integrity, authentication and non-repudiation. What is data confidentiality? Data confidentiality is designed to protect the data from the disclosure attack. That is, using the crypto system the data can be protected. Okay, so no one can access the data without the permission. Okay, that is data confidentiality. Then we have data integrity. Data integrity is designed to protect the data from modification, insertion, deletion, replying by an adversary. Okay, that is using the crypto system services, the data can be protected. Okay, it can't be modified or inserted, deleted by some other person. That is crypto system services. Then we have authentication. Authentication is what it provides the authentication of sender or receiver during the connection establishment. Okay, that is, it provides the authentication for two persons for the communication. Okay, then non-repudiation service protects against repudiation by either the sender or the receiver of the data. That is, here the repudiation is nothing but the sender or receiver. Like, the sender might not send the data, but still he says that he has sent the data. So that is repudiation. So this non-repudiation services protects against the repudiation. Okay, that is the crypto system services. Okay, then next we have cryptographic methods. Cryptographic methods are, we have symmetric, asymmetric and then hybrid methods. Okay, what is basically symmetric? Symmetric means the same key for encryption and decryption. We use the same key for encryption and decryption algorithm. Then we have okay, in asymmetric there will be pair of keys for encryption and decryption. Like we have public and private key. Okay, we will study about here later. Then we have hybrid. Hybrid is nothing but combines both strength of both the methods. That is what symmetric and asymmetric. Okay, that is hybrid. Okay, we'll see about the symmetrical algorithm. What is symmetrical algorithm? In sense, I told that we use the same key for the encryption and decryption. Okay, it is also called as secret key cryptography. Okay, here we have single key. That is, single key is used for both encryption and decryption. That is, the sender encrypts the plain text using this key and sends the ciphertext. This receiver, what he does is, using the same key, he decrypts the ciphertext and gets the original plain text. That is the symmetrical algorithm. In symmetrical algorithm, examples are, we have data encryption standard, then advanced encryption standard. Okay, these are the examples. Okay, let's now see these examples in the crypto. Okay, basically you need to first install the crypto. The crypto can be installed. You can get the crypto using the www.cryptool.org. In that you can download the crypto. After downloading, you will get the you can install and you can get the this page. Okay, what is this? This is the crypto main screen. In this we are now will see we have encrypt decrypt. This encrypt basic we have symmetric, that is symmetric classic algorithms, then symmetric modern is nothing but DS, AES, triple DS, this one. Then in classic we have beginner cipher, hill cipher, substitution cipher, phase cipher, etc, etc. Okay, then hybrid comments are both, that is RSA. Then we have in asymmetric we have RSA encryption. Okay, now let's see the DS example. Okay, this is DS. For encryption we should have key to encrypt the message. Okay, so for this what we do is first go to this first go click on this. You'll get hash. In hash go to MD5, click on that. Okay, click on that, you will get this key. Copy this whole key, copy this key, then close this. Okay, then open encryption. In that we'll get DS. Okay, in DS then paste the code that you copied. Okay, then now use encryption. This is the encrypted message. Actually this is the original message, that is starting example for the crypto version family. This is original text. Now what after encryption will get this is the after DS of encryption of the message. So this can't be readable by anyone. So what we do is for decrypting this message, same what we do is go to here, then decrypt this DS example, then paste the same code, then decrypt it. So after decrypting you will get the same original message. So this is the plain text. After applying the DS algorithm we will get the cipher text as like this. So then to get the original message back, then go to this. When you get the after decrypting you will get this one. Okay, this is called DS encryption of the message, then DS decryption of the message. This is the plain text. Okay, got it. Now let's go back to the PPT. Okay, then we have asymmetric algorithm. What is asymmetric algorithm? I have told that in asymmetric algorithm we use the pair of keys. What are the pair of keys? One is private key and then public key. Private key is used for the decrypting, public key is used for the encrypting. Okay, let's see the example. Here we have John and Mary. Okay, so this John encrypts the message using the Mary's public key and sends the mail to the internet. So what this Mary, what she does is after receiving the message, she first decrypts the message using the Mary's private key. Then she will get the original text message what is sent by the John. Okay, this is asymmetric algorithm. And hybrid crypto system is nothing but combines the both the features of symmetric and asymmetric. Okay. So a key encapsulation, in this what we have combines both things. Key encapsulation scheme, which is public key crypto system, and data encapsulation scheme, which is a symmetric key crypto system. Okay, this is the hybrid crypto system. What is this? This is Pauli. He will send the message using this, that is symmetric key encrypted with the Pauli's public key. Using his public key, he will encrypt the message. Then he will send it to the this. Okay, then this Pauli what does decrypts with the Pauli's private key. Okay, this is combination of both asymmetric and symmetric. Then we have cryptanalysis. What is basically cryptanalysis? Cryptanalysis is nothing but the study of methods to break the crypto system. Crypto system is nothing but what? That is the protection of the message. In cryptanalysis, what we do is basically we concern to that is break the crypto system. That is getting the protected information. Okay, then how we do is that is often target at obtaining the key. Main in crypto system is the key. So what we do is to break the crypto system, we will target at the obtaining the key. These attacks may be passive or active. Okay, then we have Ketchup principle. What it says is the only secrecy involved with the crypto system should be the key. Okay, that we know that is secrecy involved in the crypto system is what key. So in crypto Ketchup principle says that guessing the key should be so difficult that there is no need to hide the encryption and decryption algorithm. Okay, so that is this, that guessing the key should be the very difficult, so that we no need to hide the encryption decryption algorithm. That Ketchup principle. Then we have cryptanalysis attack. There are several attacks are there. Now basically we'll see some of the attacks. Okay, brute force attack. What is brute force attack? Is nothing but trying all the key values in the key space. Like brute force, the name itself says that trying all the key values like continuously, A, B, C, D, while trying all the keys, we'll get the to get the plain text of the ciphertext. That is brute force attack. Then we have frequency analysis. What is frequency analysis? Nothing but guess the values based on the frequency of the occurrence. Like nothing but will be suppose how many times the same word is repeated. That is called frequency analysis. That is, if sometimes 2 times it is occurred, then we'll guess the key based on the types of occurrence. Then we have dictionary attack. Dictionary attack is nothing but find plain text based on the common words. Okay, based on the common words. In English we use the common words is nothing but like I, E will be there in the I, E, A will be there in the almost all the words. So we'll find the plain text based on the some common words. Okay, then we have replay attack. Replay attack is nothing but repeating the previous known values. Previous known values will be there, then repeating that will get the original message. That is the crypto. Then we have ciphertext only, known plain text, chosen plain text, then we have chosen ciphertext. These are again 4 attacks are there. Okay, now let's see what is ciphertext. Ciphertext only attack. In this attack, what is this? We have, for example, we have Alice and Bob. Okay, then Alice and Bob, and Eve is the one who attacks the message sent by the Alice to the Bob. Okay, then first Alice, Alice do is he will encrypt the message and sends the ciphertext to the Bob. So while sending the ciphertext, Eve what Eve did is what you do is it has the attack. Okay, it will attack the ciphertext and doing some and applying some algorithm, that is analysis, will get the plain text. This is called ciphertext only. Okay, it will the Eve has access only to the some ciphertext. Then we have known plain text. What is known plain text? Known plain text is nothing but format or content of the plain text available. That is, plain text will be available. Okay, that is, Eve has access to some plain text or ciphertext page in addition to the intercepted ciphertext that she wants to break. Example, that is, Alice sends ciphertext to the Bob. Okay, Eve what Eve does is it will first it will attack the ciphertext, and you will be having some access to the plain text. Okay, it will be having some access to plain text, so it will decrypt it using some algorithm, then compare with the plain text, and you will get the original message. That is known plain text. Then you have chosen plain text. Chosen plain text is similar to that of the known plain text, but the plain text or ciphertext pairs have been chosen by the attacker herself. Okay, that is, in the sense, in this in chosen plain text you will be having the some plain text. Okay, but in this what it is, it will be Eve you will choose the some plain text to check the decrypted message using the sent by the Alice. Okay, that is chosen plain text. Then we have chosen ciphertext. What is chosen ciphertext? Is decrypt known ciphertext to discover key. Okay, in chosen ciphertext, Eve has access to the some ciphertext using to the Bob. Okay, that is, Alice sends the some ciphertext. It will take this ciphertext and it will decrypt it. And what then after it will has some, after decrypting it will check. Okay, after then this can happen if Eve has access to the Bob's computer. If Eve can access the Bob's computer, then it can easily attack the original message. Okay, then we have ciphers. What is basically cipher? Cipher is the algorithm for performing the encryption or decryption. Okay, encryption, to perform the encryption or decryption we use the cipher algorithm. Then we have in cipher, the categories of ciphers are ciphers. In cipher we have classical, classical cipher, router machines, then modern. Again in classical we have subdivision as substitution cipher, transposition cipher. Then in modern we have private key, public key. Private key again as stream and block. Okay, then let's see the let's go for next thing. Okay, first basically we have substitution cipher. Substitution cipher is what converts one letter to the another. That is like substitute. The name itself says that substitute one letter with the another letter using the some type of the algorithm. Okay, we in substitution cipher we have monoalphabetic cipher. Monoalphabetic cipher was invented by the Julius Caesar. This is the table given by the Julius Caesar. That is this, we can say A is substituted by the D, and B is substituted by E, C is substituted by F, like that. Okay, continuously it can. This is the table given by the Julius. We can change it. Okay, then the for example, hello world can be encoded as a Kurzgesagt using the Caesar cipher. Okay, let's see this example in the crypto. Okay, this is the crypto we have. Okay, I'll close this. Okay, I'll close this. We'll take new example as a hello world. Hello world encryption using Caesar. That is symmetric class. Under classic we have Caesar. Okay, using Caesar. This is after clicking this you will get this. Okay, Caesar. Then alphabetic character is A, starting from A. Then okay, we'll give to change the okay what you want to change. There we have given is D. Okay, so D. You can give any number. If you give C, it will start from C. So yeah, so A is substituted by the C and B is substituted by D, like this. So like this it can go. Okay, we'll first put D1 so that we can match example. Okay, so now encrypt it. After encrypting we will get Kurzgesagt. That's what here. So hello world can be encoded as a Kurzgesagt using the Caesar cipher. Okay, this is the algorithm. And again if you want to decrypt it, again same thing, go for the classic Caesar cipher. After then put D, decrypt it, and get the original message. This is the plain text. This is the cipher text of the encryption using the Caesar type. Then this is decrypted using the Caesar algorithm. Okay, this is called Caesar thing. Then we'll go for next example. Okay, then we have okay, now we have seen monoalphabetic. Now we will see polyalphabetic cipher. Polyalphabetic cipher we have in polyalphabetic we have Playfair cipher, AutoKey cipher, and Wigner cipher, and still some other etc. Okay, let's go for Playfair cipher. What is this Playfair cipher? Is nothing but the key table for the Playfair cipher is given as like this. The Playfair cipher consists of 5 cross 5 matrix. In 5 cross 5 all the 26 letters will be there, except in 26 we have only 25 boxes. In 25 boxes we will fill all the letters. In this in case of in one place the I and J can be same place, I and J can be put. Okay, this is Playfair cipher table. Then okay, what is actually Playfair cipher? Playfair cipher is how it works is, first plain text message is split into pairs of 2 letters. Okay, if there is an odd number of letters, a Z is added to the last letter. Let us say we want to encrypt the message hide money. It will be written as like this. Okay, what in Playfair cipher is do is will divide the given plain text into two letters. Okay, two letters, that is this. Then if any if an odd number of letters are there, then we'll add the dummy letter Z or X or something, that is there. Okay, after adding this, or if any okay, this is the rule. Then the rules of the then one more thing is, if if suppose M and M are there, then we'll add the dummy letter X or Z to next to M, and then that is continuous next. Okay, then the rules of the encryption are, if both the letter, okay, what are the rules in the Playfair cipher? If both the letters are in the same column, take the letter below each one. Okay, example, see this. Now what we are doing is we are high demo. Okay, H and high is what? we have the cable, that is H and I, both are in the H and I are in the same column, hence take the letter below them to replace it for the ciphertext. That is H is what? Q. Below letter is Q, and then for I below letter is C. So I will be encoded as QC. Okay, this is the first rule. Next rule is, if the both letters are in the same row, take the letter to the right of the each one. Okay, that is we have, next is what? We have DE and DE are in the same row, so hence take the letter to the right one of them. Okay, suppose DE are the side same row are there, then D's next letter is what? E. E's next letter is what? F. So D will be encrypted as EF. Okay, got it. Then we have next rule is what? If neither of the preceding two rules are true, from a rectangle with two letters and take the letters on the horizontal opposite. Example, if the two letters are not in the same column or not in the same row, they it will be like this. Then what we'll do is, M and O, see, M and O are nor on same column nor on the same row. So hence from rectangle as shown, replace the letter by picking up opposite corner letter on the same row. MO as NU. Like what? M and O can be encoded for M and O, encoded intersection of the letter is what? N. So that is N. And for O and M will get U. Okay, got it. This is M and O. For M and O, N, and O and M will get U. This is the Playfair cipher algorithm. Okay, let's see in the crypt tool. Okay, first we'll go this. Okay, first we'll give some example. Playfair cipher. Hello world. Okay, in hello world we have two letters. Okay, if two letters are there, we should add one dummy letter. Then check if it is even number or odd number of letters. 2, 4, 6, 8, 10. It is odd number of 10. Okay, so no need to add the last exa dummy variable. Now encrypt using, that is more classic Playfair cipher. Okay, this is a Playfair cipher. In Playfair cipher you will see duplicate letters, that is first separator, second separator. Then okay, this is the first separator. What you want? Like first separator is nothing but if two letters are there. Second separator is if like odd number of letters are there. Okay, odd number of letters are there. Now check, this is the table is given. Now we encrypt. Okay, after encryption, this is the plain text. Plain text is first converted to, after encryption, that is Playfair pre-formatting. Pre-formatting is what I said is, first divide the given letter into two letters, that is HELX. Why LX is nothing but, I told that if two letters are same in the same, that is adjacent, same to the adjacent, we will add the some dummy letter. Dummy letter is what? X. Okay, then LO, VO, RL, then DX. Why DX is, last left is only D, that is odd number of letters. So what we do is, we will add one more dummy. It should be two letters, so we will add again dummy letters. This is the rules. Okay, this is the encrypted. So encrypted messages, this one. After encryption we will get the HE is, how it HE is like this. Okay, we can check example. This is Playfair. Okay, so now H and E, check whether H and E are the same row or same column or no. Okay, H is here and E is here. So these both are neither in the same row or in the same column. So what we should take is, we should take the intersection of the letters, these two letters. So HE, for HE will get the K. Okay, that is this K. For E and H will get C. So that is C. So he will be replaced by KC. Okay, next we'll go for LX. Check whether LX are in the same row or same column or neither. That is L is here and X is here. This is same case. So what we'll do is L and X. So intersection of these letters is what? V. So okay, sorry, L and X. L and X is what? This is N. Okay, and then X and L is what? V. So that is this NV. Same thing for all the letters. Okay, this is the okay. So one more is this DX. We'll check for DX. DX is what? D is here and X is here. Okay, then X and for D and X, D and X is what? For D and X intersection of is C. X and D intersection is Y. That is C. Okay, understood. This is the working of the Playfair cipher. Now next, let's continue for this. Next we have transposition cipher. Okay, what is transposition cipher? Is change the position of the letter in the text. Okay, that is old jumble, that is changing the position of the letter in the text. Okay, keyless we have in transposition cipher we have keyless transposition. Okay, keyless transposition, key transposition. In keyless transposition we have first method and second method. What is first method? First method is what? The text is written into table column by column and then transmitted row by row. That is this. First method is what is? We'll write the in table, we'll write in column by column, then that is transmitted to row by row. Second method is what? The text is written into the table by row by row. First what we did is we written by column by column and transmitted by row by row. Here what we are doing is first writing it in the table as row by row and then transmitted it to column by column. Okay, understood? This is transposition cipher. Then we have rotor machine. Okay, what is rotor machine? Rotor machine was invented by the German engineer, that is Arthur Krebs. Okay, this is the rotor machine. In rotor machine we have these are the rotors, that is left rotor, middle rotor, right rotor. That is shown here. Okay, so this is reflector. Okay, what we will do is here, that is A word is right, that is we have after rotating to thrice, that is left, right, middle, left, we'll get it as G. Okay, that is we'll get it as G. So this is the rotor machine working. So after rotating we'll convert the original message into some other text so that no one can be attacked. Then we have private key and public key. In private key that is stream cipher. Okay, what is stream cipher? Is nothing but a secret key encryption algorithm that encrypts the single bit at a time. Okay, nothing but it only encrypts the bit by bit. Okay, for example, we have the binary of the plain text is nothing but this is argument. Okay, key is what? This. So what the stream cipher says is it encrypts only the single bit by bit. Okay, at a time, single bit at a time. So using some perform XOR of operation, we'll get the cipher. That is 1 and 1. XOR will do 0. 0 and 1 XOR is 1. So we'll get the cipher text. This is the cipher text of the using the that is stream cipher. Okay, to decrypt, make the XOR operation of the cipher text with the key. Okay, so for this is cipher text. Again, to get the original message, what we will do is XOR operation of the this cipher text with the this key to get the this original key. Okay, that's the stream cipher. Then we have block cipher. Block cipher is what? This is the techniques involve encryption of one block of the text at a time. That is one block of the text at a time. What in that was only single bit at a time. Here it was one block of the text at a time. That is decryption also takes one block of the encrypted text at a time. Length of the block is usually 64 or 128 bits. For example, here the plain text, that is 4 and 5. So 4 is separate and 5 and is separate and 5 is separate. So what it is block cipher, that is it encrypts using the block. This is a key. We'll get the cipher text as like this. Okay, this is the cipher text. Then same for the decryption of this. After like for while decrypting, we'll do to get the original message. Stream cipher, block cipher. Then we have public key crypto system. Now seeing the private key over. In private key we have stream cipher. We had stream cipher and then block cipher. Now we have public key crypto system. In public key crypto system is what? Cryptography scheme that uses a pair of keys for the encryption. As I told earlier, in public key we use two keys, that is a pair of two keys. That is one is private key and is private key, and another one is public key. Okay. That is here example private key and public key. Here in as an example, that is Alice and Bob. Okay, the Alice, what Alice does is that it encrypts the plain text, using the Bob's public key. Okay, this Bob, what is this? It gives the public key to the Alice. Okay, so that Alice can encrypt the plain text using the Bob's public key. After encryption, it sends the cipher text to the Bob. Now in Bob, in the receiver side, that is Bob, what Bob does is it decrypts the cipher text sent by the Alice using the Bob's private key. Okay, Bob will be having the private key and public key, or public key for the Alice encryption and private key for the decryption. So decrypts using the Bob's private key to get the plain text and reads the plain text. Okay, this is the public key crypto system. Then you have message authentication. Okay, message authentication is necessary because to get the authentication, so that no one can access the information, okay, without the authentication. What we have MAC. Okay, what is MAC is, that is message authentication code. MAC algorithm is a symmetric key cryptography technique to provide the message authentication. That is, to provide the message authentication, we use the MAC algorithm. What is MAC is message authentication code. Okay, so we will be having one code to authenticate the message of the sender and the receiver. For establishing the MAC process, the sender or the receiver share the symmetric key. So in MAC, what we'll do is, in MAC we use the same key both the sides. That is, in sender side and receiver side, we'll use the same key for encryption and decryption. Okay, along with this MAC key. And essentially, MAC is an encrypted checksum generated on the underlying message that is sent along with the message to ensure the message authentication. Okay, like what is MAC is? MAC is what? Encrypted checksum. Okay, MAC is nothing but type of the checksum that is generated on the underlying the message. Okay, that is using the message, the MAC code is generated, that is sent to the for the authentication for receiver. Okay, this is the, for example, like sender and receiver are there. So the sender, what is a sender, first using this MAC algorithm, this message will generate the MAC key. Okay, this is a MAC key using the using some algorithm generates the MAC key, that is called MAC code. Okay, so this MAC code along with the message, the MAC is sent to the receiver. What receiver says, using the same algorithm and using the same the same key, he will also generate the MAC code. Okay, MAC code, and checks if the received MAC and generated MACs are equal. If it is equal, only then only then you can get the message or information. So like this authentication will be performed. So this is called message authentication. Okay, then we have cryptography benefits. Okay, what are the cryptography benefits? We are using the cryptography in many fields, like bank for authentication to get the message, to protect the messages and all. Okay, so what and all benefits are there? So here we use some benefits are confidentiality, authentication, data integrity, and non-repudiation. Okay, what is confidentiality? Confidentiality is like we in cryptography use the encryption technique. Encryption technique can guard the information and communication from unauthorized revelation and access of the information. Okay, in cryptography use the confidentiality. So what are the uses of in confidentiality is what it protects the information from the unauthorized persons. Okay, unauthorized persons, like example, in bank only the user, that is customer, and the bank only gets the user's account. No one can else know the user account, so no one can get the message. That is called confidentiality. Then authentication is what the cryptography technique such as MAC and digital signature can protect the information against spoofing and forgeries. Okay, in cryptography we have authentication techniques, like nothing but we have MAC. Okay, just you have seen MAC. Okay, so using this, so we can protect the information from the spoofing or forgeries. Like no one can forge the in bank example, in bank where no one can like you have the okay, no one can get the withdraw the money without your signature. so that is called authentication. Then we have data integrity. Data integrity is what the cryptographic hash functions are playing vital role in the assuring the users about the data integrity. Data integrity is what we have some in data integrity, that is using the hash functions. What we do is in cryptography we have hash functions, so that we can't so no one can modify your account, or no one can like after modifying some people can modify and get. So using the cryptography technique, so no one can hack your account and get the money or something else. So that is benefit of cryptography. Then we have non-repudiation. Non-repudiation is the digital signature provides the non-repudiation service to guard against the dispute that may arise due to denial of passing message by the sender. As is told that non-repudiation, that is nothing but that is the sender may send, like suppose if two people are communicating, the sender that is two people are communicating, the sender might not send the data, but still he says that he has sent the data. So that is called repudiation. So this using the cryptography, this can be what it can be avoided. Okay, that is called so that is why using the cryptography. Okay, now we have seen the cryptography benefit. So what are the drawbacks of the cryptography? Drawbacks is the main drawback is nothing but that is strongly encrypted, authentic and digitally signed information can be difficult to access even for a legitimate user at a crucial time of decision making. Okay, what it says is like even the legitimate user cannot be access the particular information, like because of it. So that the cryptography is so strongly connected, that is encrypted and authenticated, even the in some decision making time even the legitimate user can't access. That is one of the drawbacks. And one more is what cryptography comes at cost, that is cost in terms of time and money. How is like addition of the cryptography technique in the information processing leads to delay. Okay, so we use the addition of the cryptographic technique. So for sending the messages to for other person, receiver, we'll add some cryptographic technique and we'll encrypt it, and then ciphertext will be sent to the receiver, and the receiver will receive the ciphertext and it will decrypt it, and then to get the plain text. So here there will be lots of delay. Okay, so you'll get the message, it is time consuming. So that is one of the main drawback. Then one more is what the use of the public key cryptography required setting up and maintenance of the public key infrastructure, requiring the handsome financial budget. One more is nothing but cost. Okay, we use the public key cryptography. Okay, so it takes the so for maintenance and setting up of the public infrastructure will be very costly. So this is the main drawback of the cryptography. Okay, okay, finally this is the okay. Thank you everyone for viewing this video. Okay.